Hey there everyone, welcome to part 6 of my Santa platformer tutorial. This is the last video in the series and this video will be jam-packed full of content. We're going to be dealing with enemies, we're going to be dealing with particles, objects. If you haven't already, be sure to check out the previous videos in this series. We got a lot to cover, so let's get right to it.
Let's create our first enemy by going to the Snoomba folder. Isn't it cute? Let's first set up the pixels per unit to 300 and apply. We'll then select the idle and walk frames and drag it out onto the scene to create an animation, where we will save it in our animations folder and call it Snoomba Walk. We're going to need to modify the animation a bit, so I'm going to drag out my animation tab out here for a second and move my shy Snoomba from behind Santa where everyone can see him. In our animation timeline, I'm going to drag out the contents of the third frame over to the fourth. And with the third frame selected, I'll hit record and drag the idle frame onto the sprite. This will create an animation that consists of idle, walk 1, idle, then walk 2. Totally adorbs. Look at its little feet. Let's move back the animation tab so it's not in the way and add a new layer called enemy. While I'm at it, I'll rename the game object so it's not Snoomba Idle, just Snoomba. And to little Snoomba, we'll add a Capsule Collider 2D. We'll change the direction from vertical to horizontal, change the X size to 1.22, and the Y to 0.77. I'll also adjust the Y offset. We'll also add a rigid body 2D, change its gravity scale to 4, and lock the Z axis. And I'll scooch little Snoomba down to the ground so it's not floating in the air. Next, let's add a few scripts so we have the ability to create various enemies. We'll go to our scripts folder and add a new script called abstract enemy. This will be an abstract class.
So an abstract class is basically like an idea of a thing. We can take a vehicle as an example. We all know what a vehicle is, but there are different implementations of what a vehicle can be. For example, the obvious one would be a car. But bikes can also be a vehicle, and so can a skateboard. We all know a vehicle needs to move forward, but how it moves forward changes depending on what the implementation is. Some vehicles can even move backwards, sideways, some float on water. For our purposes, we want to have an abstract class of an enemy. There's going to be different implementations of how the enemies will behave, but there will be commonalities between all of them.
To create an abstract class, we'll add the keyword abstract to just before the class. There will be a few variables that will be common inside all enemies, which we'll take from inside our character controller class. We'll grab everything from movement and ground detection. We'll also grab current direction. We can delete animator and after image, horizontal tilt, and also the jump section. Because we will be using an abstract class, we need to change private to protected to allow all inherited classes to access the values of these variables. We'll need a new variable, protected float wall distance, which will allow the enemies to detect if it hits a wall. We'll also need a boolean is dead to prevent movement for the enemy after it's been defeated, which is false by default. We'll create two abstract functions, update movement and check walls. These functions will behave differently for each enemy, so we'll declare them here, but implement them when we create our enemies. In our start, we'll initialize some values, starting with current direction equals transform.localscale.x. And we'll grab a rigid body with underscore RB equals getComponent rigidBody2D. Now, we will create some functions that all enemies will need to use, starting with public void defeat, public void check wall, and lastly, onDraw gizmos, which we'll copy from our character controller. To that, we also want to draw out the wall lengths to see if our enemy will hit a wall. So we'll copy these two lines and change down to right and ground distance to wall distance. In the next line, we'll change it to left as well as change ground distance to wall distance. Let's move up to check wall. For this function, we want to check if the enemy has hit a wall. If it does, we want to change the direction we are facing and move the other direction. For the detection, we will set bool hit equals physics2d.raycast. Transform.position plus collider offset times current direction. We'll use conditional branching with if current direction equals 1, question mark, then the value will be vector3.right. Otherwise, vector3.left. The distance will be wall distance, and we will detect ground layer. We will add an OR, copy the statement, and change ground layer to destructible layer. And then if there is a hit, we'll change the current distance to the negative of itself. For the defeat function, we definitely don't want to run this if it's already dead, so we'll start with that. For the logic, we'll first change the layer as the first layer of preventing the enemy from being able to collide with anything else. Then we want to disable the colliders to prevent hitting other objects physically. We'll then pop the enemy with a force, and we'll flip the enemy upside down, all culminating into a magnificent death animation. For the code, we definitely want to start off with something I missed here, which is set isDead equals true, followed by gameObject.layer equals layer mask dot name to layer default. Next, getComponent capsule collider 2D dot enabled equals false. getComponent rigid body 2D add force vector2 dot up times 5 or any other number you want force mode 2D dot impulse. To flip it, transform.localscale equals new vector3 transform.localscale.x -1, 1. In our update function, if the enemy is already dead, then we won't continue with the function. Otherwise, we'll call update movement, check wall, and check ground. We'll implement this into a new script called snoomba enemy. The first thing for the script is we'll change mono behavior to abstract enemy. This is how we implement the abstract class. We'll then get rid of the start and update and copy the two functions we need to implement back in abstract enemy. We'll change abstract to override and add curly braces to make these functions complete. For the update movement, we need to get the game object to face the current direction. Set a current speed and clamp it. Then apply the speed to the velocity. Transform.localScale equals new vector 3, current direction 1 and 1. Current speed equals mathf.clamp, current speed plus acceleration times current direction, negative max speed and max speed. Underscore rb.velocity equals new vector 2, current speed underscore rb.velocity.y. For check ground, we'll copy what we had in abstract enemy for check wall. We want to know if there's no more ground in front of the enemy, and if there's no more ground, we'll change directions. We'll change the conditional branch to simply vector 3.down. And do the same for the below statement. We will then change the wall distance to ground distance for both. And since we don't want there to be ground when we change direction, we'll change this to not hit. Let's drag our Snoomba script onto our Snoomba. And we'll adjust our collision variables starting with ground distance. We'll then adjust wall distance, and we can see a horizontal line appear for the wall detections. And on the collider offset, we'll adjust the X to move the lines just to the edges. Then we will assign our layer variables. I want the enemies to be much slower than our Santa, so let's change that. Let's move our Snoomba here so there are ledges. And there's our little Snoomba. Let's add some interactivity between enemies and Santa. We'll add a new header for Santa. While we're at it, I want the player to lose if it falls off a ledge, so we'll set a minimum Y position. We will also add a boolean for if Santa is dead, which is false to start. In our update, we don't want to be able to control Santa if we are dead, so let's add that on top. Next, we'll create a function to call when we die, as well as a coroutine that will reset the game when the player dies. For death, we again don't want to run this if we are already dead. We'll set isDead to true, then start the coroutine. For the coroutine, we first set velocity to 0, flip Santa upside down, pop Santa with a force, disable the capsule collider, then after 3 seconds we'll reset the level. Rigid body.velocity equals vector 3.0. transform.localScale equals new vector 3, current direction, -1, 1, just like the Snoomba. We'll copy the jumping code from our start jump function. Get component capsuleCollider2D.enabled equals false to disable the capsule collider. Yield return new wait for seconds 3. Of course, you can change the 3 to anything you like. If we ever wanted something else to happen after death, we would put it here. But for now, we'll just reload the scene. Unity engine.scenemanager.load scene 0. I'll also fix this typo I have up here. And then we'll go into our onCollision enter 2D function and add conditions for the enemy. I'll copy this part right here and then put else if, pass in the condition, and change destructible to enemy. We'll have two conditions here. First, if we are slamming or dashing, then we will defeat the enemy with collision.getComponent abstract enemy, since we want to defeat any enemy, .defeat. If we aren't slamming or dashing, we'll call onDeath. Now if we touch the enemy, we die. Or we can defeat the enemy with dash or slam. The death doesn't look quite right, so here's where I go back to the Snoomba and set the dead to true in the defeat function. And now we're good to continue on. Back in our update function, in character controller, we'll add the condition of where you can die if you fall below min y. And now we can fall to our doom. Let's make a new type of enemy by first copying our Snoomba game object and get rid of the animator and Snoomba script. Let's also replace the sprite with a winged 1 frame and drag them out into the limelight. Adorable. We'll also move it closer to the ground and flip it by changing the scale X to -1 and rename the game object to Hopper. Let's give it behaviors with a new script called Hopper Enemy. In lieu of animations, we'll simply change the frames of Hopper depending if it's on the ground or not. So we will create sprite variables called ground sprite and air sprite. We'll also have hopper jump, not hop, so we'll need a float jump height. And a float jump delay to give it some time between jumps. Also, don't forget to change mono behavior to abstract enemy before copying the contents of Snoomba into Hopper. The movements we can keep the same, but for check ground, let's copy the logic of check ground from character controller. If the hopper is on the ground, we want to tell it to jump after a short delay. So I almost forgot that we will also need a boolean will jump. This will ensure that hopper will only try to jump once. If we're not on the ground, set will jump to false. If we are on the ground and will jump is false, we first set it to true to make sure we won't jump again, and then we start the coroutine. We will call the coroutine delayed jump. First, we'll swap to the ground frame. Next, we will wait for the delay time. Then we swap the frame to the jump frame and add a jump force. We'll assign the sprite renderer to SR with getComponent sprite renderer. Then set sr.sprite to ground sprite. We will now wait with a yield return new wait for seconds jump delay. Swap sr.sprite to airSprite. And lastly, go to our character controller to copy the jump force math and apply it here. Now, let's go back to the check ground and call our coroutine. We can drag our script onto Hopper, adjust the collision variables, assign the layers, and drag winged 1 to ground sprite, and wing 2 to air sprite. Now we have an enemy that hops around. Sorry, jumps. Now that our enemies are finished, let's drag them into prefabs and move them aside for now. Let's make some cookies. We'll go into the collectibles folder and set everything to 300 pixels per unit. We'll then drag a cookie onto our scene. Let's create a new layer called collectible. And assign it to the cookie. Next, let's add a circle collider and set it to a trigger. Back in our character controller script, we'll add a predefined Unity function called onTriggerEnter2D. We first want to make sure the layer of that object is a collectible. If collision.gameObject.layer equals layerMask.nameToLayer collectible. After that, there are several things we'll do. First, we'll add to a score. Then, we will make the sprite invisible and disable the collider. Then we'll play some sort of animation. The only thing we can do right now is making the sprite invisible and disabling the collider. So, first, gameObject.g equals collision.gameObject, and then g.getComponent circle collider 2D enabled equals false. g.getComponent sprite renderer dot enabled equals false. Now our cookie disappears on contact. Let's create a method for keeping score with a new script called scoreKeeper. For scoreKeeper, we'll have it act as a singleton. Without getting into too much detail, a singleton in Unity is an object that will always exist in the game, and there can only be one instance of this object at all times. To create this, we'll start with public static scoreKeeper instance. We'll also need inScore and set that to 0. Let's get rid of these functions and add private void awake, which acts similar to start, but has some differences, which I won't get into for this video. For the awake, if instance equals null, instance equals this. Else, destroy game object. And finally, don't destroy on load instance. This ensures there's only ever one instance of this object, and it won't be destroyed when changing scenes. Next, I want a getter for the score, which we can use to display it. So I will write public int score get return score. We'll also need a function to add to the score, which we will call add score, and it takes the int value. Inside, we can just write score plus equals value. In our scene, let's create a new game object called scorekeeper and drag our script into it. Back in our character controller script, we'll need to add a reference to the scorekeeper called _sk. And in start, we'll use GameObject.find scorekeeper, which is the name of the object, and getComponent scorekeeper, which is the class we wrote. Back in our onTriggerEnter function, we'll use the function to add 1 to the score. To display it, we can temporarily write into debug log. Now we can grab a cookie and see a score of 1, die, then grab another cookie and see that our score is now 2. Let's add some particles to our cookies. We'll add a new component, particle system. That doesn't look too great, so let's add a new material. Inside our collectibles folder, let's create a new material called stars. We'll drag the star image into the albedo map, then change the shader from standard to particles, standard unlit. For the rendering mode, we'll change to cutout. Back in our cookie, we'll scroll down to our particle system and expand renderer. We'll then drag our new material into the material slot under renderer, and we'll see our stars emitting. Back up top, we will configure the particles. Duration will be 1. We will turn off looping, but we can still hit play to see the particles. Start lifetime will be 1, and for speed, we'll change to random between 2 constants, being 1 and 3. Size we'll set to 0.5. Max particles we'll set to 10. Then we'll expand emissions and add a new burst, which will be 10 at 0 seconds. Let's expand shape and set it to a circle and change the radius to 0.1. Then we will check the size over lifetime, expand it, and set the curve to a linear line going downwards. We can hit play to see the results. Lastly, we'll scroll up and turn off play on awake. And for cleanliness, let's drag the star material into the materials folder. To get it to play, we'll go to our TriggerEnter function and add g.getComponent particlesystem.play. Now we have stars, but they play behind Santa. In our script, we want to move the game object closer to the camera so it draws in front of Santa. So we will add g.transform.position equals new vector 3, g.transform.position x, g.transform.position y, negative 0.05 f. Perfect. Let's drag the cookie into our prefabs to make it a prefab, and further tidy up our scene by putting loose objects into empty game objects. Next, let's create some UI so we can display the score on screen. we will right-click and create a new UI image. This will automatically create a canvas to display our UI. Double-click on canvas and it'll zoom up to show the full canvas. Let's change the UI scale mode to scale with screen size. Then we'll rename our new image to cookie. And under images, we'll drag the cookie image into the sprite. We'll adjust the size, change the anchor to top left, and then adjust the position. Next, we want to create some text to display the score. I won't be covering Text Mesh Pro in this video, so for now, I'll just create a UI, legacy, text. I'll change the text to 0, change the color to white, adjust the size, the position, and I'll also add a new component, shadow, which I'll set to 2 and -2. This just gives the text some contrast from the background. In order to properly get the score to show, we'll create a new script called UI controller. For the script, we first want to use unityengine.ui. This allows us to write code for the UI components in Unity. Next, we'll add a text variable called scoreText. And we'll also want a reference of scorekeeper called _sk. In start, we'll just set _sk to GameObject.find scorekeeper getComponent scorekeeper. In our update, we will change scoreText.text. If _sk.score is greater than 0, we'll take _sk.score.toString. Otherwise, it'll just be 0 in quotes. Let's drag that script into our canvas, and then drag our text object into the text variable. Now we can see our score being displayed. Next, let's create some particles for whenever we destroy rocks. Just as we did for the stars, we'll create a new material. Called rock particles. I'll drag the image onto the albedo and change the shader to particles, standard unlit, and change the render mode to cutout. And then we'll move this material into our materials folder. In our prefabs folder, let's click on the large rock, and in the top right, we'll click open. This will modify all instances of our large rock, even the ones in the level. Just like the cookie object, we're going to add a new component, particle system. We'll drag our rock material into the renderer, and the settings will be largely the same as the cookie particles. Now that that's done, let's copy our particle system, open our small rock prefab, and then we'll paste components as new. And then we'll modify the particles just to make it fit a little bit better. Back in our try-destroy platform function, we're going to get the particles to play just as we did with the cookies. First, we'll go g.getComponent box collider 2D enabled equals false. g.getComponent sprite renderer dot enabled equals false. g.getComponent particle system dot play. Since we no longer want to destroy the game object, we'll get rid of this line here. And just like the cookies, we'll move the object towards the camera just a little bit. So we'll copy this part up here and paste it down here. And now we have particles for when we destroy rocks. To finish the game, I want to make the goal this Christmas tree right here, which can be found in our collectibles folder. I'm going to drag it onto the scene. It's a little small, so I want to adjust the pixels per unit to a smaller number. That looks much better. I'm going to add a new layer called Goal. And then I'll apply a box collider 2D. I'll thin it down to roughly the size of the trunk, and I'll set this as a trigger. Next, let's write a new script called Goal, which will act as a behavior to happen when the player touches the goal. For now, that will be just to change the scene. Inside the script, we'll first have a string next scene, which will be the name of the scene to load. We'll create a function, completeLevel, that will be called whenever the level's complete. For now, we're just going to use this to change the scene to a different scene. So first, we'll implement using Unity Engine Scene Management. To change the scene, we'll use Scene Manager .load scene next scene. Back in our character controller, for the onTriggerEnterTwoD function, we'll add a condition for the goal. For this, we'll write collision.getComponent goal.completeLevel. We'll drag the script into our tree, and then for the next level variable, we'll put it as level 1. When we make contact with the tree, the level should restart.
And that's it for this series, everyone. We now have a fully working game where we can further add to it or leave it just as is. And as always, if you have any questions, comments, or concerns, be sure to leave it in the comment section below. If you enjoyed this series, guys, be sure to hit that like button and subscribe to see more videos. I hope you enjoyed this series. I had a lot of fun making this, and with that, I'll see you in the next one.